Every year, 250,000 tons of gelatin are consumed worldwide. With a market valued at over $3 billion, Asia is the largest producer and consumer of gelatin. But do you know how this product is made? In this video, you'll see all the stages of gelatin production, from collecting the raw material to the final packaging. Gelatin was originally developed by Peter Cooper, an American in 1845. His invention solved the problem of food preservation before the refrigeration era, allowing the creation of products with a longer shelf life that helped preserve perishable ingredients. This innovation was especially valuable during the First and Second World Wars, providing soldiers with a source of protein that was easy to store and transport, used in military rations to feed the troops. Over time, gelatin also became a key component in the manufacturing of medicine capsules, making their preservation and consumption easier. In addition, it allowed for the creation of desserts and products with innovative textures, increasing the versatility of ingredients and offering easy-to-prepare options. Gelatin is a protein substance derived from animal collagen, extracted mainly from the skin and bones of pigs and cattle. It is colorless and soluble in hot water, forming a semi-solid and elastic texture when cooled. In the food industry, it is used to make desserts, sweets, and meat products. Its gelling and stabilizing capacity makes it a fundamental ingredient in the production of various foods and nutritional supplements. But how is gelatin made in the factory? The production of gelatin begins in meat processing plants, where raw materials with a high collagen content are meticulously selected. The raw material comes mainly from pigs and cattle, whose bones, skins, and connective tissues are rich in this valuable protein. When the animals are slaughtered, the cuts of meat intended for human consumption are carefully separated, while the collagen-rich parts, such as bones and skins, are collected for further processing. These raw materials are essential. They are transported in refrigerated trucks to factories specialized in gelatin production, where they remain under strict temperature controls in order to prevent decomposition and ensure the highest product quality. This factory receives a delivery of 5 tons of skins and bones every day. Upon arrival, bones and skins go through a meticulous cleaning process to remove impurities, fat residues, and meat leftovers. This step is essential as the purity of the extracted collagen depends on the complete removal of contaminants that could affect the texture, color, and taste of the gelatin. For this, washing systems with water and special solutions are used, designed to dissolve impurities without damaging the collagen structure. This gelatin factory is one of the largest in the world. It can produce more than 10,000 bags of powdered gelatin per day, which are then distributed to the market. The factory is made up of huge stainless steel containers connected by an intricate network of pipes and ducts. This sterile environment prevents any contamination and allows for precise regulation of key factors such as temperature, pH, and concentration, ensuring optimal production. After being sanitized, the materials go through a size reduction process to facilitate the next extraction phases. The bones, which are particularly hard and dense, go into powerful industrial grinders that turn them into uniform fragments of approximately 2 centimeters. The skins, on the other hand, are cut into thin strips by high-precision blades. Once reduced to the ideal size, skins and bones are immersed in huge tanks of hot water at 70 degrees Celsius. This heat treatment serves a dual purpose. It helps dissolve the collagen fibers and breaks the molecular bonds that hold them together, thus releasing a liquid solution rich in proteins. To improve the solubility of collagen in the solution, an acidifying agent is introduced, usually vinegar. As the collagen dissolves, it forms a viscous and dense solution, similar to concentrated broth. However, at this initial stage, the liquid still shows noticeable turbidity due to the presence of solid residues and undissolved particles. From this point, the solution enters a purification phase to eliminate any residual impurities. To purify the solution and obtain a more refined product, a filtration process is applied. In the factory, this step is carried out using high-precision ceramic microfilters. Under enormous pressure, the solution passes through filters with microscopic pores imperceptible to the naked eye, resulting in a completely clear and purified liquid. The result is a clean and homogeneous collagen broth, which will serve as the liquid base for the gelatin. In total, the filtration process runs through approximately 3,000 meters of piping. Despite this meticulous process, there are still some residues of dissolved salts and a high water content left. To eliminate them, the mixture passes through huge containers filled with tiny synthetic resin beads, whose function is to attract and retain the salts. Next, the collagen solution is pumped through extensive stainless steel pipes and subjected to an evaporation process in large tanks, until a dense and viscous concentrate is obtained, with a consistency similar to honey. From every 2 liters of collagen solution, only 200 milliliters of concentrate remain. To ensure stability and microbiological safety, the gelatin undergoes brief heating, which eliminates any remaining microorganisms. Then the concentrated liquid cools down slowly. As it cools, the collagen turns into a semi-solid and elastic gelatin. The concentrate is pressed through a perforated disc, forming the characteristic gelatin threads. These filaments fall onto a conveyor belt, where they dry progressively. During this process, hot, sterile air evaporates the remaining moisture. Next, the completely dried gelatin threads are ground into a fine powder. Once the gelatin has been dried and converted into powder, it is mixed with other ingredients to add flavor, color, and improve the texture. First, sugar is added, which provides the necessary sweetness to enhance the flavor and ensure the product's stability. pH regulators such as citric acid are used, as well as flavorings which allow for a wide variety of flavors, such as strawberry, lemon, or orange. In addition, colorants are incorporated, which can be of natural origin, such as beet extract or turmeric, or artificial. Finally, stabilizers and anti-caking agents are added to prevent the powder from compacting and forming lumps inside the package, ensuring its ease of use and preservation. Finally, the product is packaged. And that was today's video. Remember to like and subscribe to the channel.